Namaste students. It is second part of the lesson quadrilaterals today. We are going to learn the adjacent sides of a quadrilateral. What does that mean? Adjacent. Adjacent refers to sitting together. Sitting together means they are in contact. Okay, they are touching each other. Adjacent. Also there is another word, co-sides, consecutive. So, how to identify the sides in any polygon? We have learnt in the last class. The sides are line segments, right? They are denoted by two capital letters. The ends of the line segments are used to name the line segment. We have learnt for, say, quadrilateral is ABCD. If this quadrilateral, say I want to name it as ABCD, then the sides are AB, BC, CD, DA. So while naming the quadrilateral, we have learnt that we cannot skip the vertex. So like how I trace the path starting from one point till I come back to the same point without lifting the pencil. Same way we name. We are not supposed to name in a different way. As I said, no lifting the pencil. We come back to the same point. Which vertex we start, that becomes the first vertex. And the last vertex we meet becomes the fourth letter of the name. We are not writing the first letter again. Okay, there are four sides as we already learnt. Quadra refers to four. Quadrilateral means four-sided. So there are two pairs of adjacent sides and it is not just two pair, there are two more, because in each vertex there are two sides meeting. If you observe, just focus on the point A, which is one of the vertex. Which are the two sides which meet at A? AD and AB. So those two are adjacent sides. Okay, those two are adjacent sides. So if you imagine that a person is standing at A and he is having his arms open, stretched on both the sides. While doing the mass drill, you will be stretching your both arms to the left and right, right? So if it is like that, a person standing at A, what are his arms? AB and AD, right? So when I say AB and AD, that A letter comes in both, and that is the common vertex, remember. So it is the vertex which is common, and say somebody is standing there and he is stretching his arms, he will be having those two as the sides. So adjacent sides means two sides of the quadrilateral. They are always referred for two sides because sides plural it is. Adjacent sides. And if they are having a common vertex, common means that vertex should be there in side AD also, and the same vertex should be there in side AB also. That means same person's two hands. Same person's two hands stretched towards left and right. So person head is same, no? So you can imagine that vertex is head and the arms are sides. So common vertex. Arms are stretched. So adjacent sides means two arms from the same vertex. So there are four vertices, no? So observe here. Now I am showing one of the adjacent sides, one pair of adjacent sides. When we refer to two objects, we say a pair. So it's a pair of adjacent sides. Now I have named AB and BC. What is the common vertex? It should be there in AB also, it should be there in BC also. That vertex is vertex B. So B is the common vertex for the side AB and BC. When I say AB and BC only, you can hear B twice, right? You are listening. B is twice. So the vertex B is there in both AB and BC. So that is the common vertex. Now another, see here, it's highlighted in purple. CD and DA. CD and DA. Where do they meet? The adjacent sides CD and DA, they meet in vertex D. Is that over? In this figure I have highlighted only 2 because I cannot highlight another. We have chosen now vertex B and vertex D. But remember, at vertex A, as I already explained, AD and AB are adjacent sides. I couldn't color it with the same color because already they are different colored. So AD and AB are also adjacent sides. At the vertex C, CB and CD are also adjacent sides. I have highlighted only 2 pairs. There are 4 pairs because there are 4 vertices. Clear? Okay, you should know now. If I ask what is the vertex, what is the adjacent side at the vertex B, then you should say AB and BC. Remember this. It comes in higher classes also. Now moving on to opposite sides. Okay, opposite sides. It's very clear. The ones which are adjacent means they are sitting together. If they are not sitting together, then they are called either non-adjacent, something like opposite of adjacent, non-adjacent, or they can be called as opposite sides. Non-adjacent sides and opposite sides mean the same. Sometimes opposite means exactly opposite, it will be there. Sometimes slightly it will be that side. That depends on shape of the quadrilateral. If the quadrilateral is not having this kind of very clear picture, AB and CD may be slightly, CD can be slightly slanting also. We have seen other day different kinds of quadrilaterals. It can be drawn by joining any 4 random points. Random means points can be anywhere on the plane, isn't it? They don't have something like here only it should be. Like that we don't have any such fixed location. So opposite sides means, how do you say now? AB and BC are not opposite, remember. So skipping one of the side which don't have common vertex. Okay. So opposite sides means the 2 sides of the quadrilateral, if they don't have a common point or common vertex, then they are opposite. Observe here, the now 2 red colored sides are highlighted. They are opposite. Another, AD and BC. They are also opposite, isn't it? So now do we find any other pair? Here only 2 pairs, right? Do we find any other pair? AB and CD only, right? Because AB and AD already taken for adjacent sides. Now AB and CD are opposite. BC and AD are opposite. We don't have anything else. Now, adjacent angles. We have studied that angles are denoted by single letter, single capital letter. It's a corner, right? So if 2 angles are sitting together or they are next to each other, next vertex is called, at that vertex whatever angle is formed is called adjacent angle. Okay, adjacent vertices, vertex B and vertex C, angle formed at those 2 vertices, they become the adjacent angles. So vertex B and vertex C are adjacent. Vertex C and vertex D are adjacent. Vertex A and vertex D are adjacent. So again there are 4 pairs of vertices which are adjacent. So if somebody says name the adjacent vertices, you can't say B is adjacent vertex. It's wrong. Because adjacent means always it comes next to each other. Two things should be there. So because consecutive, that's what I said, consecutive, next to each other, continuous, co-vertices. So they are sitting together. Now the angles made there are called adjacent angles. Simple. They have one common side. Common side means what? The side which connects them. Right? That vertex belongs to that side. Vertex B also belongs to BC. Vertex C also belongs to CB. Right? Because that side says, no, you both vertices, you both come to me, you belong to me. I am your friend. Observe here. Upon BC only, the angles are sitting. That's why I highlighted those angles, also the side. Because those angles are adjacent angles. Side is not actually called that part of that, but still side is, the angles are holding the side, right? You can imagine, or the side is holding the angles. So it is common side. That is why we call these two as adjacent angles. There are 3 more, as I already said, as there are 4 pairs of adjacent vertices, there are 4 pairs of adjacent angles. See, observe, green colored. One more. So now the common side between these two green angles is highlighted. So one is red, one is green. Now the one which is above, AB, black one, that is common side. If I consider vertex A and vertex B, angle A and angle B are also adjacent. But I can't mark it with same color. Already they are one marked in green, one marked in red. Remember. Correct, no? Okay. So there is also one more. Angle D and angle C. They are also adjacent. So there are 4. I have listed all of those. And for whichever common side highlighted, I have written which is the common side. Others also have common side. Angle C and angle D is having CD as common. Because that letter should come, no, vertex should come in the side. Opposite angles. There are only 2 opposite angles. How many diagonals are there for a quadrilateral? 2, right? It is given in your textbook. Okay, there are 2 diagonals for a quadrilateral. Do we know what is the reason that there are only 2 diagonals? Because there are only 2 pairs of non-adjacent vertices. As we already learnt, non-adjacent vertices means A and C, non-adjacent. A and B are adjacent only. Vertices A, point B, adjacent. So if I join that, what I will get? Side only. But if I join A and C, non-adjacent vertices, I get one diagonal. There are only 2 such pairs of non-adjacent vertices. Therefore, what do we get? 2 diagonals we get when we join that. Now, I am not telling about here the diagonals. What is written in slide is different. It is mentioning about opposite angles. Don't think that B and C are opposite angles just because they are marked in red. Angle B and angle D are opposite. Similarly, angle C and angle A are opposite. So angles are to be marked, right? Yes. See, angle B and angle D are marked using same color. One more pair is here. They are also marked using same color, green. So there are two pairs of opposite angles, four pairs of adjacent angles, four pairs of adjacent sides, two pairs of opposite sides. What is this? Observe carefully. There is a light sky blue colored quadrilateral drawn, and the angles of the quadrilateral, can you see which are the angles marked inside the quadrilateral? Don't observe that circle now. In one corner of the quadrilateral there is a circle. So I want you to observe the quadrilateral alone. Inside there are four angles marked, right? A, B, C and D. Angle A is marked using green color, B is marked using blue color, C is marked using purple color, D is marked using red color. So what happens? It's a random quadrilateral. Okay, this quadrilateral is random in the sense it's drawn in Watrasi manner. It's not actually having any particular rule. Just identify 4 points, join using scale. Whatever you obtain is called quadrilateral. Mark the angles. So now, in case you cut these angles and try to join these four angles in one single point, as shown in the right side. Can you see right side? Four line segments are combining and four angles are joining at one point. A point is marked where angle A, angle B, angle C and angle D are combined. It's mathematically called coinciding. They come and join together at that point. What is observed? Do they make one complete circle? Yes. So it is 360 degree. Full angle. One complete angle is 360 degree, right? So it tells that any quadrilateral which is drawn either convex or concave has the angles adding up to 360 degree. You can try this. I have given one small homework last at the end. You have to draw any choice, your choice, as per your choice, one random quadrilateral. Take the protractor. I think you are very good at measuring angles. So write the measurement of each angle. Measure it and write the measurement. Add it. You will get it 360 degree. It's so nice to observe. When you do it for some 5-6 quadrilaterals, it is really interesting to find out that angle comes out as 360 degree. So you can verify this. Also there is one file here, video file. You will see that it illustrates clearly that movement shows graphically showing how angles are forming one complete circle. Okay, now mathematically how do we prove? Something called theorems. It is there in your textbook. How do we logically arrive at the result? Just because we observe by cutting and pasting or by measuring, can we always say that it is true? Mathematically we need proof, no? So how to do that? Observe this. One random quadrilateral again drawn ABCD. And the angles are marked. Angle D is 2, named as angle 2. Angle C is angle 3 plus 6 because it is cut into two equal parts. So observe, I have drawn one of the diagonal using red color intentionally so that I can prove it. We have studied that for any triangle, three angles add up to 180 degree. Angle sum is 180 degree, half circle. Now can you see two triangles? When diagonal is drawn, the angles of the quadrilateral, they split themselves into the angles of the two triangles. So angle 1 and 2 and 3, they are the angles of the triangle ADC. Right? You have studied in your lower classes. Similarly, angle 4 and 5 and 6, they become the angles of triangle ABC. Now let me use the same angle sum property of the triangle. Angle 1, angle 2, angle 3, 180 degree. Angle 4, angle 5, angle 6, 180 degree together added. Now add all the 6. 3 angles plus 3 angles. They 6 angles become 4 angles of the quadrilateral. So what do you get? 180 plus 180, 360 degree. It is due to logical proof. We have used only angle sum property of the triangle and we have concluded and proved that angle sum of any quadrilateral is one complete circle. It is 360 degree. You should know this. Check the theorem given in your textbook. It's very interesting. Understand this. Of course, you need to know what you have studied last year about the angle sum of a triangle. Now, this is another illustration. Illustration means what? Pictorially representing so that it is very, very clear. Okay, after the video is shown, so video, if you see properly, you will understand what is this. Now the quadrilateral is again like one of the quadrilateral is having first picture of the quadrilateral. It is all 5 pictures, same quadrilateral, no change in that. First it will be like that. 4 angles are marked, one with blue, pink, brown and green. Now the green angle and the pink angle, if I am cutting using the diagonal, say it is cut into 2 triangles. The green angle becomes divided into 2 equal parts, K1 and K2. Not equal, 2 split parts. If I name that angle as K1 and K2, they are sub parts, no? They are friends. So when they combine, they will become full angle K. Similarly, pink, I didn't name it. So it is shown in the picture, you will understand. H is same, M is there and the green angle K1 and K2. See where it goes and sits, that yellow arrow mark. It is shown from the pink, it will come and sit there near M. Similarly, that K2 will come and sit there near M. So that will become 180 degree. The blue colored M will become 180 degree because of half of the pink and half of the green. If you see the second picture, you will clearly understand. Picture 2. Half green cut, K2 cut, and it is coming and sitting near M. And half of the pink cut. So it is coming like flag and coming and sitting there. So that angle M became now 180 degree. Same manner, now K1 goes and sits near H. That green part goes and sits near H. And the other pink goes and sits near H, upper side. So again 180 degrees formed. So together 4 angles of the quadrilateral, first we had marked H, K1, K2, M and pink angle. Now it is showing one half circle, another half circle. What does that mean? It is 360 degree. Yes. Don't worry if you cannot understand this. You can try it by yourself. When you just draw any quadrilateral, use crayons and highlight using any different 4 color. Cut those angles only. Vertex should be marked with small bindi or something which is very clear. Vertex should be marked before cutting. Now join the vertices like that, how it was shown in the previous slide. So you will get one complete circle. That's more than enough. This is just pictorially given because we cannot show it right now. Same way, you may be wondering if the quadrilateral is concave, will it be true? Yes, it will be true. Even if the quadrilateral is concave, angle will be 360. Remember this. Observe carefully. I will give a half-minute time. K will be going and sitting there. M will go and sit. What about Y? That also will go and sit there to make 180 degree complete. So 2 half circles are formed. Is it clear? See the angle that K and M together. One of the angles of the concave polygon is more than 180 degree. That is why we said no yesterday that 180 degree, if it is more than 180, it will be called concave. That is the reason K and M together makes more than 180. Inside the quadrilateral you have to observe, not outside. That white portion, whatever, off-white. Now coming to the questions, problems, what we say in mathematics. Math textbook has plenty of problems, it seems. So what happened, one day it was worrying, I am full of problems. Then children like you approached the textbook and you solved the problems and the textbook is happy now. So keep solving problems, okay? That will help solve our own problems. Okay, now question number 1. The angles of a quadrilateral are given 100 degree, 98 degree, 92 degree. 3 angles are given. Find the 4th angle. Just now we studied that angle sum of a quadrilateral will be 360 degree or one full circle. So we are using the property, angle sum property. So just write, add the 3, then for the unknown angle name it as x. Then find the unknown angle. Normal method, it's easy. Second one, the 4 angles of the quadrilateral are given 2:3:5:8. What is this? It's a ratio, correct? Yes. So if one angle is 2, second angle is 3, third angle is 5, fourth angle is 8. 8 portions or 8 parts. So whenever it is like this, we take it as, if it is 2:3:5:8, 2x, 3x, 5x, 8x. That's how we take it. In algebra you will learn this. It is the easiest method. Otherwise in your textbook you have ratio method also. Add all the terms in the ratio. Then first part will be that whatever 2 divided by 18, because 2 is first part of the ratio, and there are totally 18 parts, 2 plus 3 plus 5 plus 8. So 2 by 18 into 360 degree, that also can be done. Or you can do like this, this is easy. 2x plus 3x plus 5x plus 8x. That comes out as like 360 degree, it will be 18x is equal to 360. Or you can do directly in the ratio method as 1 part is equal to 360 degree divided by 18. Then find out if 1 part is 20, 360 by 18, what will be 2 parts, what will be 3 parts, you have to find out. This is easy, either that method or this, anything is okay. You have to write and learn these questions. Remember, these problems and all you should write down, and also the property, any simple clue given to help remember like what it is, you have to write it down, otherwise it is not remembered, we always forget. Third question, the measures, degree measures of two angles are given, 115 degree and 45 degree. Then it is also given that the other two angles are equal. When other two angles are equal, we can take both of them, each of them as x. Unknown angle 1 also x, unknown angle 2 also x. So 115 degree plus 45 degree plus x is 360 degree. Then the same rule, whatever we followed previously. 115, 45, add it, x plus x is 2x. It is something like 1 apple added to 1 apple. That's why x plus x is 2x. X and y cannot be added. 1 apple and 1 banana we cannot add, remember. That's why like terms can be added. So x plus x is 2x. In algebra, I hope you have studied. Otherwise, you will study it. So 2x you will get it as 200 degree, x will be 100 degree. Always cross check your answer yourself. 115 plus 45 plus 100 plus 100, is it 360? You can check always. So this is the method. Very simple questions, because when we solve these kind of questions, the property will be always remembered by us and we will be using it. That's called application. One more is there, very much similar. I leave it to you. I am not explaining. I have given the method. It is very easy. Three angles are equal. One angle is 108 degree. So you have to take three of them as x, x, x. Now adding 3 times x, 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 you will get 3x. 1 apple, 1 apple, 1 apple. Added is 3 apples. Or you consider it as banana, 1 banana, 1 banana, 1 banana added. That's how we learnt algebra. It is very easy. Now, fifth question. If you see the picture only, you will be able to tell the answer. So simple it is, first one. But whenever asked in the exam, this is how we write. Okay? X is unknown, 3 angles known, 50 degree, 130 degree, 120 degree and all. So you should write it as x is equal to 360 minus 3 given angles. But the 3 given angles should be within the bracket. So add first, get the answer, 300 degree you will get, subtract that 300 from 360, 60 degree will be the answer. Second one, question B, fifth main B. You can see one red colored M, that we have to first find, otherwise we can't find out what is the value of x. One x is unknown, but m is also required here. To find that m, here we are using linear pair. Okay, the property which is true everywhere. When two angles are there on a straight line at any one point, those two angles sum will be 180 degree. So 90 degree is shown there. 90 degree is symbolically represented like that only, small l. So M is 90 degree. Now 90 plus 60 plus 70 you should find. Then that answer should be subtracted from 360 degree. That's all. It's very simple. So let me move to the last question.